Okay, today we want to talk about combining functions and operations on functions. Operations you're familiar with: addition, subtraction, multiplication, division. Can you think of other operations outside of those four? Exponents, square roots, absolute values. Oh, now you're stealing all the answers from first hour. You can take the sine of something. You can take the logarithm of something. Those are also operations. Later on this unit, I'm going to give you two new operations that you've never seen before. They are called composition and they are called inverse. There's certain operations you can do with functions. Today we're going to talk about combining functions using our main four: addition, subtraction, multiplication, division. F plus g of x is the same as f of x plus g of x. So if you look at example 1, it says find f plus g. F plus g of x, what do? I simply take f of x, which is x squared, and I add it to x minus 1. And I get x squared plus x minus 1. Hopefully that feels pretty straightforward. Yeah? So I couldn't, I'm sorry, I didn't want to sound so, I couldn't tell if you were joking or if you were being serious. Okay, so f of x is x squared. G of x is x minus 1. So I'm going to add them together. You simply just take x squared plus x minus 1. Subtraction, f of x minus g of x. F minus g of x. Take x squared and I subtract g of x. What do you think you have to do with the subtraction? Distribute all the way through. So it's a minus x and it's a plus 1. When you multiply, take f of x times g of x. F of x is x squared. G of x is x minus 1. Multiplying, we get x cubed minus x squared. And if you divide them, f divided by g of x, you get f of x, which is x squared, divided by x minus 1. All right, like Mr. Gantz, we don't really need a whole lesson on that. You could just send us a memo and an email. We would have understood exactly what to do. One thing that's very important about this, and this is the whole reason why we're doing it, is we're trying to get at the domain. What do we know about the domains of these things? Forgot to write the division up here. For the domain, it happens to be the domain of f intersecting the domain of g, or the overlap of the two domains. Same thing for subtraction. Same thing for multiplication. And same thing for division, except g cannot be equal to 0. Why do you think that last one says that g cannot be equal to 0? Can have 0 in the denominator. Very good. So, if we want to identify the domain of these functions, we look at the original. F of x is x squared. And we think of that domain. What's the domain of a parabola? Negative infinity to infinity. All real numbers. What is the domain of x minus 1? All real numbers. What is the overlap between all real numbers and all real numbers? All real numbers. Therefore, the domain is negative infinity to infinity for the first 3. For multiplication, for addition, for subtraction. But when you look at the last one, when you look at division, You think all real numbers, except I have to consider where the denominator will be equal to 0. What would you plug in to g of x to make 0? You would plug in 1 to make 0, correct? So if you plug in 1 to make 0, x cannot be 1. Pretty simple. We'll try 2 more examples. What's different about letter B? Square roots. When you have square roots like square root of 5 plus square root of 7, can you add those together? Can you simplify that at all? No, you can't. So f plus g of x, being the radicans are not the same, you just have the square root of 2 minus x plus the square root of x squared minus 9. And for the subtraction, you have square root of 2 minus x minus the square root of x squared minus 9. If I have the square root of 5 times the square root of 7, could I simplify that? Square root of 5 times square root of 7 is square root of 35. You can multiply them together. So f times g of x, I'm going to multiply these two together. 2 times x squared is 2x squared. 2 times negative 9 is negative 18. Negative x times x squared is negative x cubed. And negative x times negative 9 is positive 9x. Same holds true if you divide them. You can write them both underneath one square root sign. 2 minus x over x squared minus 9. So now what we would like to do is we would like to consider the domains. I'm going to go to a separate board so that I can have a little bit more room to work. We want to consider the domain of 2 minus x, square root of 2 minus x, and square root of x squared minus 9. Square root of 2 minus x and square root of x squared minus 9. How do I consider this domain right there? What do I do? Can you plug in anything? Is it all real numbers? Why? I take square root of negative, so I set it up as 2 minus x greater or equal to 0. Must be positive or equal to 0. Subtract the 2, negative x greater or equal to negative 2. Divide by negative 1, x less than or equal to 2. Oh boy. All right. X squared minus 9. Square root of x squared minus 9. What do I do there? X squared minus 9 greater or equal to 0. How do I do a quadratic that's greater or equal to 0? Got to graph it. Goes through negative 3 and positive 3. So where is it greater or equal to 0? Negative infinity and negative 3, union with 3 to infinity. So we want to consider the overlap of those two. We want to consider the overlap of those two. Negative infinity to 2 and then negative infinity to negative 3 and 3 to infinity. Where is the overlap? Yeah, negative infinity to negative 3. So providing a graph can really help you understand what the domain looks like when you look at the overlap. So our domain, negative infinity to negative 3. negative infinity to negative 3, negative infinity to negative 3. And I'd like to say the same for the last one, but I have to exclude any values that would give me 0 in the denominator. What will give me 0 in the denominator? 3. Is 3 included in this domain? So I don't need to worry about 3. Negative 3. How do I exclude negative 3? Yep, negative infinity to negative 3. Use a parenthesis. Good. Last example. I'm going to let you guys have some time to work here. F plus g of x. What's different about this one? Got some fractions going on here. Can you add two fractions? What do you have to have? Do you have common denominators? So watch how quickly this goes. We got 4 plus 2x over x minus 1. If we subtract them, we've got 4 minus 2x over x minus 1. How do we multiply fractions? Yep, straight across. And we get 8x over x minus 1 quantity squared. And how do we divide two fractions? Good. We multiply by the reciprocal. So as you see, 4 over x minus 1 divided by 2x over x minus 1. What we say is you multiply by x minus 1 over 2x. What will happen when we do that? X minus 1's cancel, you get 4 over 2x. 4 over 2x will simplify to 2 over x. Now let us state the domain. What's the domain of f? X can't be 1, domain of g. So the overlap, x can't be 1. All the way down. However, the last one is just a little bit different. What would you say is the domain for the last one? And you're only half right if you say that. And here's why. When you're taking f divided by g, you must consider it. This is f divided by g. You must consider it before you actually go through the simplifying of the situation. So notice as I look at this, I actually have 3 denominators, don't I? I have this denominator with the green arrow. I have this denominator with the red arrow. And then I have this whole thing is a denominator as well, isn't it? So we have to look where any of those denominators would be 0. What would give you 0 for the green or the red? 1. So x cannot be 1. So I consider the green and the red. How about this section right here? Okay, look at this guy right here. That is a denominator, correct? What would you plug in for x that would make this 0? 0, yeah, 2 times 0 is 0, right? And see, that pops up right here. So it's x can't be 1 and x can't be 0. So you need to consider it before you simplify it. Okay? Good. I'm going to hand out your assignment. You're going to be given about 12 minutes to be working on it. And then we're going to get to our last little part on this section, which is looking at other domain problems. Okay? Good work. That we're going to now engage in. Suppose you had a function, the square root of 2 minus x plus 1, and you wanted to identify that domain. Well, we haven't looked at a function like that before. We just graphed a lot of functions through transformations not too long ago. However, I could divide this up into 2 functions that are added together. I could call this one f and this one g. See how that's 2 functions that are added together? Well, I know the domain of x plus 1. What's the domain of x plus 1? All real numbers. And I know how to find the domain of the root of 2 minus x. I say 2 minus x is going to be greater than or equal to 0. So negative x is greater or equal to negative 2. So x is less than or equal to 2. That means my domain is from negative infinity to 2. So How do I determine the domain as a whole? I look at the overlap between these two. What's the overlap between negative infinity and 2 and all real numbers? Negative infinity to 2. So the whole point of this section is to be able to have you look at domain in a more analytical way. I want you to be able to, on this test, be able to identify domain of some crazy looking functions. Like, look at this, x cubed times 1 minus x. You may not recognize what that will look like if we were to graph it. Well, I'm going to say it's f times g. And we know how to deal with f times g. What's the domain of f? All real numbers. What's the domain of g? All real numbers. One's a cubic, one's a line. So the domain together is going to be from negative infinity to infinity. You see a problem like C, I ask the domain. You're like, I've never seen that function before in my life. We don't care. We'll make it easy. Look at the top, look at the bottom. The top is a cubed root. What's the domain of a cubed root? All real numbers. What's the domain of a parabola? All real numbers. So you say the domain will be all real numbers, except you know you can't divide by 0. So what will give you 0? So x cannot be positive or negative 3. The next one, you have the same reaction. Oh my gosh, I've never seen a cubed root plus a fourth root, a cubed root minus a fourth root. Well, we'll say that it's two functions that are combined through subtraction. We have multiple functions together. What's the domain of f? You can't take the fourth root of negatives though, right? So you take 2x minus 7 and set it greater than or equal to 0. Or 2x is greater than or equal to 7. Or x is greater than or equal to 7 halves. So that will be 7 halves to infinity. So you're going to look at the overlap of all real numbers and 7 halves to infinity, and you get 7 halves to infinity. So again, we're taking functions that look complicated. We're making them easy. Last two examples. Top and bottom, domain of x squared. All real numbers. Domain of x cubed plus 1. All real numbers. But we can't divide by 0. What would give you 0 in the denominator? Negative 1. So x cannot be negative 1. Last one. Have no idea what the function looks like. But I make it into two functions, f and g. The domain of g, that's easy. It's a polynomial. That's going to be all real numbers. And hopefully now you've seen the square root of 3 minus x enough that you recognize that the domain is going to be from negative infinity to positive 3. The overlap is negative infinity to positive 3. And that's that. That's the point of what we just went through, that you can now look at functions that look more complicated and still identify the domain and say something intelligent. Good work. You got 5-6 minutes.